Okay, so 8-3, trigonometry of missing sides. And today's learning intention is I will learn how to use trigonometry ratios to solve for missing sides of a triangle. And I wrote on a triangle, okay? Missing sides on a triangle. And so once you get that learning intention down, go ahead and get your squares down, your perfect squares. Okay, 1, 2, and 3 is going to be a little bit of a review. So we have the square root of 169. A couple ways we can check on that. We either might know it in our head or we can check on our chart and we can see it right here and it does come out clean to 13. Or you can simply put the square root of 169 in your calculator. If it doesn't come out into a decimal, then you know it's fine just like that. Let's look at the square root of 44. That is not on our chart. It's also, if we put it in our calculator, it's going to be a nasty decimal. So we need to come up here and do a little bit of work. So let's see here. The square root of 44, we want to look for the largest perfect square. And if we come up here, we see 36 is too big. 25 is probably too big. So we want to ask ourselves, does 16 go into 44? Nope. What does? 4. 4 is the largest one. And how many times? And if you don't know, you can just put 44 in your calculator and divide it by 4, and it's actually 11. Okay? Or we should know that 4 times 11 is 44. Now, we are not finished. We can simplify more. The square root of 4 is 2, and radical 11 is reduced all the way. So when we look at number 3, this is one of those where we notice 4 is on the outside of the radical, so it's going to come down for the ride for right now. And then we need to focus on radical 18. And what is the largest perfect square that goes into 18? Seeing probably 9. Okay, 2 times. Okay, so the square root of 9 is 3 times radical 2. 4 times 3 is 12. Radical 2. Any questions on those? Okay, very good. Okay, now if you are using a graphing calculator, and a lot of you might be, since we're not able to use the TI-30s, the thing is, and this is good for you guys to know, it cannot be in, it has to be in degrees. It cannot be in radians. So if you're getting wrong answers or they're not matching up, that might be why. And so if you don't know how to turn it back, you know, please come see me. All right. So let's look at what we got here. I'm going to go ahead and label A, B, and C, and I'm going to make these all capital letters. And I'm going to go ahead and circle A, and we're going to focus on that a little bit. Now, this is my big A, and we learned a couple chapters ago, the opposite of big A is over here. Notice how it's not touching it. It's opposite, and this is going to be little a. And I'm going to say that this is opposite. Okay? And then I have big C over here. Well, let's do big B first. So I have big B. So down here I'm going to have little b. And this is adjacent to my big A. I circled my big A, so this is the one that I'm kind of like going to be working with today. And so my little b is going to be adjacent to this guy. And then my hypotenuse is always the longest one, or across from the right angle. So that's going to be my little c. And notice it is opposite. Okay? And then we're going to talk about something that's called theta. And this is my missing angle, or the angle I'm looking for. So I should have probably put this first, but theta is the angle I'm trying to find. So that's why I circled big A. And that's how I know that little a is opposite. It is not touching it. Little b is adjacent. Notice it is touching it. C is touching it, but we're always going to call that the hypotenuse. Okay, so let's look at the next one. Once again, I'm going to look at big A again. And so little a is 4, which is opposite, right? Okay, so I'm going to put a little O for opposite. And this one is adjacent. And once again, I have my hypotenuse. Okay? And I'm going to turn this to adjacent, opposite, hypotenuse. Okay. So we're going to learn some new things. So the sine A, so sine of A is going to be 4, is going to be opposite. So the opposite over hypotenuse, or that is the same as 4 over 5. And my cosine of A is going to be adjacent over hypotenuse. Whoops, I'm going to fix my pen here. Adjacent over hypotenuse. So that's going to be 3 over 5. And my tangent does not have a hypotenuse involved. And so that's going to be opposite over adjacent, which is going to be 4 over 3. And we're going to talk about these in a little bit more detail. So if you're confused, that's okay. Okay, so once again, sine. Sine is opposite over hypotenuse. And cosine is adjacent over hypotenuse. And tangent is going to be opposite over adjacent. Okay? And so there has been acronyms to help us with this. It goes back many years, and it's SOHCAHTOA. Kind of like soak your toe, but it's SOHCAHTOA. SOHCAHTOA, yep. Yep. And so here we are. So the S is for sine, which is like this, sine. And this is opposite over hypotenuse. Okay? And the CA is for cosine. And this is for adjacent over hypotenuse. And the TOA is tangent, and that's opposite over adjacent. Okay? And so right now, we need to get our calculators out, and I want to look at them, and I want to identify the buttons and find where they are, sine, cosine, and tangent. Okay, so let's get our calculators and see if we can find those buttons. Okay, so let's look at number 1. It says, put the information given in the picture and solve for the wanted variable. Okay, so it's telling us measure of angle A is 48 degrees. Okay, so I'm going to circle big A, I'm going to write 48 degrees. And then it tells me little a equals 9. So where did I say little a goes? Opposite of big A? So that's where little a is, and it is 9. Okay? And then it wants me to find C. Where is my C? Where's my C again? My hypotenuse, right? Little c. I'm going to put a big H for my hypotenuse. Okay? And also, I said that this is opposite, so I'm also going to put an O for opposite. Okay? So now, I'm trying to find this. So the two angles we're dealing with is opposite and hypotenuse. So which one of these do you think we're going to be using? Sine, cosine, tangent. Sine. I have an opposite and a hypotenuse. Okay? So just so you know, if there's ever nothing about a hypotenuse, it'll be tangent. The only two that have hypotenuse in them is sine and cosine. So if we're ever dealing with a problem and nothing is said about a hypotenuse, it's going to be this one. Okay? So we have an opposite and a hypotenuse, and this is telling you how to put them. It's telling you opposite over hypotenuse. So it's like this. Sine is opposite over hypotenuse. Okay, we know that. So the way we're going to set this up is sine 48, because that's the degree of the angle we're dealing with, equals, okay, my opposite is 9 over C, because my hypotenuse is C, and that's what we're trying to find. Okay, so now it's like a proportion is set up, and now we're just solving for C. So if C is on the bottom, how do we solve for C? We don't want C on the bottom, so what do? Times it by C. Okay, now this sine 48 is actually the other side of the proportion. So if I do this times C, I want to do this side times C. Okay? So then these two C's are going to cancel out, and this leaves me with C sine 48 equals 9. And I'm still trying to get C by himself. So what do you think I would do to get C by himself? Divide by sine 48. And if I do it to this side, I have to do it to this side. Okay? And that's what lets these cancel out, and that leaves me with C equals 9 divided by sine 48. Okay? So at this time in your calculator is where you put 9 divided by sine 48. Okay, so everybody should have come up with, and I'm going to use an approximation because we got a decimal, so we're going to be rounding, and everybody should have had 12.1. Okay, next one. It says the measure of angle B is 28 degrees. Little b is 3, so here's my big B. Little b is over here, right? 3. And is this opposite or adjacent? We know it's not hypotenuse because that's this. Adjacent is touching it, so let's see. I'm going to highlight this. Is this touching it? No, so it has to be what? Opposite. So this is opposite. Okay, and then it does not give me hypotenuse. Okay, so I have B is 28 degrees, little b is 3. Okay, find A. So is it talking about hypotenuse at all? So which one am I going to be using out of these three? Sine, cosine, or tangent? Tangent. So I'm going to be using tangent, opposite over adjacent. Okay, so I would set this up by saying I have tangent, and then my degree is 28 equals, opposite of my 28 is what? 3 over, and it wants me to find little a. And little a, if this is my big A, little a is what, down here? Okay. So this is my adjacent. So little a is adjacent to big A. So opposite over adjacent. I mean, little a is opposite of big A, but adjacent to this degree right here. Make sense? Okay. So now the cool thing with this is, yeah, I think this one's set up kind of the same way. So how would I solve for A if it's on the bottom, just like we did last time? And times each side by A. Okay? And that's what gets this one and this one to cancel out, leaving me with A tangent 28 equals 3. And then how do I get A by himself? Divide. And if I do this side, I have to do this side. Let's these cancel, leaving me with A equals 3 over tangent 28. So now in your calculators, you're going to put 3 divided by tangent 28. Okay, and we should have got 5.6. All right, moving on. Okay, so let's look at number 3. 3 says measure of angle A is 70 degrees. C, where is C? C is my what? It is my hypotenuse. Find B. And B is, where's B? Over here? Okay. So I have a hypotenuse, and is this opposite or adjacent of this 70 degrees here? Is it touching or is it away from it? It's touching. So it is adjacent to. So if I have adjacent and hypotenuse, which one would I be using? Cosine. Okay? So I know I'm going to have cosine, which is adjacent over hypotenuse. Okay? So we would set this up by saying cosine 70 equals adjacent over hypotenuse. So my adjacent is B that I'm trying to find over my hypotenuse, which is 58. Okay, now I'm solving for B, so I want to get B by itself. Okay, so instead of taking each side times B, I want to get B by itself. So how do I get B over here by itself? Yep, times 58. If I do it to this side, I have to do it to this side. Okay, it allows these to cancel out, and that gives me 58 cosine 70 equals B. So here it is. If you put 58 cosine 70 in your calculator, you should get it. So let's see here, 58. Okay, so we have this, and 19.8 is B. Okay, so let's go to number 4. It's telling me the measure of angle A is 40 degrees. Little a, and little a is where across from big A is 600. Find little b. It wants me to find little b, which is over here. Okay? So is little b opposite or adjacent to this 40 degrees? Is it touching? This highlighted area, is it touching the 40 degrees or not touching? This angle right here, is it touching or not touching? Touching. Okay, so that is adjacent. And am I talking about a hypotenuse ever? No. So that means we're dealing with either sine or cosine. I mean, we're not dealing with sine or cosine because there is no hypotenuse. So we're only dealing with tangent, which is opposite over adjacent. So opposite 40 is 600 over adjacent, which is B. So tangent is opposite over adjacent. So the way I would set this up is tangent 40 equals my opposite is 600 over my adjacent, which is B. Okay? So now solving for B, I need to take both sides times B, and that is what allows these to cancel out, and that leaves me with B tangent 40 equals 600. Okay, I need to get B by himself, so do we know what we do in this case now? Yep, divide by tangent 40. Very good. We got to do it to both sides. That allows these to cancel, so I have B equals 600 divided by tangent 40, and what do we get? Okay, yep, I got 715 as well. So I'm going to change this to approximate, because we are rounding 715. All right, guys, you're doing good. Number 5. Let's see here. Number 5. Okay, number 5, it is already labeled for us. So it has our degree here, so I'm going to circle my big B, okay? My little b is over here, and I do have a hypotenuse. We notice that there's a hypotenuse. So which one? I'm going to be dealing with 2 different ones, either sew or cut. So I need to decide if I have opposite or adjacent. So let's look. My little b is over here. Is it touching this angle or not touching? Not touching. So that means I'm going to have opposite over my hypotenuse, which is sine. Make sense? Okay, very good. So I'm going to be dealing with sine. So I would set this up by saying sine 40 equals my opposite, which is b, over my hypotenuse, which is 7. Okay? So solving for b, this time I take both sides times 7. Allow these to cancel, leaving me with 7 sine 40 equals b. And now you can just put the 7 sine 40 in your calculator. Okay, what do we get? 4.5. And once again, it is rounded, so these need to be approximate. 4.5. Very good. Okay, guys, one more. Okay, so let's look. Once again, it's labeled for us. We have a 17 degrees over here on big A. And it gives us a measurement here. Does it give us a hypotenuse? It does not. So we know right away we're dealing with what? Tangent, which is opposite over adjacent. Okay? So we would set this up by saying tangent what? 17. Okay? Equals, and when we look at what it gives us, this is my angle, this is my amount. Is it touching or is it opposite? Touching. So that's my adjacent, which is on the bottom. And so my opposite is over here, so my A is on the top. All right. So to solve for A, we take both sides, what? Times 5. Okay. And I'll let you guys do the rest, and we'll come back and see what we got. All right, what did we get? 1.5. Awesome. I did too. Approximately 1.5. All right, very good.